morning, children. Welcome back to Ican Physics. Now in this class, we are going to see the capacitors connected in series. Let's enjoy the class. Let us consider a parallel plate, capacitor of capacitance C1, C2 and C3. Okay, connected in series with the source. Okay, now the source gives a potential difference of V. So potential drop across the first one is V1. Potential drop across the second one is V2. Potential drop across the third one is V3. Okay, so V equal to V1 plus V2 plus V3. So from the source, the charge Q is flowing. So the charge will be same. Okay. So what is the formula to calculate the capacitance? So C equal to Q by V. Now we are going to modify the formula for this case. Okay. So that the division V comes to this as multiplication. So V equal to Q by C. Okay. So this is the general format. For the total case, when the capacitors are connected in series, then this formula can be modified. V equal to Q by Cs. So why we are putting Cs? Because the capacitors are connected in series. Okay. Now for the first case, by using these three, how we can change? So V equal to Q by C. For the first case, the V becomes V1. Q remains same. Capacitance of the first one is C1. Okay, do you get it now? Do you have any doubts? No doubts. For the second case, V2, C2. So V2 equal to Q by C2. For the third case, yes, very good. So V3 equal to Q by C3. Now we can add V1 plus V2 plus V3. Now just see the numerator. Q is taken as common. So the remaining is 1 by C1 plus 1 by C2 plus 1 by C3. Now look at the left hand side. V1 plus V2 plus V3. V1 plus V2 plus V3 can be taken as V. So V equal to Q into 1 by C1 plus 1 by C2 plus 1 by C3. Now it's taken as equation number 2. Now compare 1 and 2. LHS are equal. So automatically RHS are equal. Then it becomes Q by Cs equal to Q into 1 by C1 plus 1 by C2 plus 1 by C3. Now Q cancel. So 1 by Cs equal to 1 by C1 plus 1 by C2 plus 1 by C3. The effective capacitance in series is equal to algebraic sum of reciprocal of capacitance of individual capacitors. Okay. So that's capacitors in series. Now do you have any doubts? No doubts. Now we are going to see. Okay. So the next one, capacitors in parallel. Capacitors in parallel. So let us consider a capacitor of capacitance C1, a capacitor of capacitance C2, a capacitor of capacitance C3 are connected in parallel. Okay. So like that it is connected with a source. Okay. So the source gives a potential V. Now all the leads or all the terminals in the left side and the right side are connected to the common terminal. So potential will be same. When the charge flowing from the source, when it comes to the junction, when it splits into the first term Q1, Q2, Q3. So the total charge Q equal to Q1 plus Q2 plus Q3. Just you can compare here. Here the charge will be same. Here the potential will be same. Here the potential will be sum of potential drop across each capacitor. Here the charge is sum of charges flowing through each capacitor. Okay. Okay. So C equal to Q by V. Okay. Here we are having V1, V2, V3. So we modify the formula as V1, V2, V3. Here we are having Q1, Q2, Q3. So that we can modify the formula. So how we can modify? Q equal to CV. Okay. Now for the first case Q1. So for Q1, how we can modify? That is Q1 equal to C1V. Q2 equal to C2V. Q3 equal to C3V. In general, or for common case, Q equal to Cp into V. Now it's taken as equation number 1. So now we are giving the name Cp. Why? Because capacitors connected in parallel. Okay. Now we can add. So when we add Q1 plus Q2 plus Q3. Now V can be taken as common. So when the V is taken as common, so it becomes C1 plus C2 plus C3. Now Q1 plus Q2 plus Q3 can be taken as Q. So for instead of Q1 plus Q2 plus Q3, we can take Q equal to V into C1 plus C2 plus C3. Now it's taken as equation number 2. Now compare 1 and 2. LHS are equal, so automatically RHS are equal. So CPV equal to V into C1 plus C2 plus C3. Now V getting cancelled. So finally we can get Cp equal to C1 plus C2 plus C3. So effective capacitance in parallel is equal to algebraic sum of capacitance of individual capacitors. So there is only one difference. Okay. Here it is reciprocal. It comes only in the numerator. Okay. Do you get it now? Do you need doubts? No doubt.